express g of x equals negative x squared plus 10x minus 21 in standard form, find the coordinates of its vertex, and determine its maximum or minimum value. Just like the last problem, we're going to have to complete the square, but because of the negative in front of the x squared, we've got to do one extra step. So we're going to start by just looking at the variable terms, and we're going to leave that constant term on the outside for now. And we need to factor out a negative. We need to pull out a negative, leaving us with x squared minus 10x. And then that minus 21 on the outside. We're really factoring out a negative 1, but we're just going to write a negative out front. And 10x divided by negative 1 is negative 10x. That's why we've got a negative here. Once we've done that, we have a situation where we've got x squared and then plus or minus some number times x, and we're now in a position where we can complete the square. We couldn't have done that when that negative was out front, outside the x squared. We need it to be outside of the whole part where we're completing the square. Now, we take negative 10 divided by 2, gives us negative 5, and when we square it, that gives us positive 25. But what we're actually doing is we are subtracting 25 from this function because there's a negative that gets distributed. So if we're subtracting 25 here, to balance that out, we need to add 25 also. And now we have a function that is equivalent to the original one. So we can factor this perfect square trinomial. That's going to be x minus 5 squared. And we can combine the constant terms. Negative 21 plus 25 is positive 4. And so we now have this quadratic function in standard form. We can find the coordinates of the vertex. Remember, we get those from h comma k. H is the number that's being subtracted from x. In this case, that's 5. So the x coordinate of the vertex is 5. The y-coordinate comes from k, which is the constant term that's being added at the end. In this case, that is 4. So the vertex here has coordinates 5, 4. Lastly, we were asked to determine its maximum or minimum value. Because the value of a here is negative, because a is less than 0, this means that we have a parabola that's opening downward, and so we're going to end up having a maximum function value. And the maximum function value is going to be 4. Remember, it's the y-coordinate of the vertex, and it occurs when x equals 5. So we found our maximum function value. We've even gone above and beyond what we were asked for because we even said when it occurs, what the x value is that causes that function to reach its maximum.